Hello students, now we shall solve an assignment problem. First we have to check whether the given problem is balanced or unbalanced. If the number of rows is equal to the number of columns, then the problem is said to be a balanced assignment problem. If they are not equal, then it is an unbalanced assignment problem. Now in this problem, there are 4 rows and 4 columns. So this is a balanced assignment problem. Now we have to follow the Hungarian method in order to solve this problem. First we have to do the row reduction. That is, we have to subtract the minimum entry of each row from all the entries of the respective row in the cost matrix. Now if we see in this problem, in the first row, the minimum element is 10. Now we have to subtract 10 from all the elements of the first row. So 10 minus 10 will be 0, 12 minus 10, 2, and here it is 19 minus 10, so 9, and 11 minus 10, it is 1. Similarly, the minimum element from second row is 5. So if we subtract 5 from all the elements of this row, we get 0, 5, 2, 3. The minimum element in the third row is 11. So we have to subtract 11 from all the elements. So 12 minus 11 is 1, and here it is 3, here 2 and 0. Similarly, the minimum element of the last row is 8. So 0, 4, 3 and 1. Next we have to move on to the next step, which is column reduction. So in this, we have to consider the matrix that we have obtained in step 1. Now we shall consider the first column. The least element of this column has to be subtracted from the other elements. The least element is 0. So we have to subtract 0 from all the elements, and definitely we will be getting the same column to be repeated. Now if we see in this, the minimum element is 2. So we have to subtract 2 from each element of this column. So 0, 3, 1, and then 4 minus 2, which is 2. The least element of the third column is 2. So we have to subtract 2 from all the other elements. So this becomes 7, 0, 0, 1. And here the last column, the minimum element is 0. So obviously 1 minus 0 is 1, 3, 0, and you get 1 over here. Now we have to go to step 3. So that is, we have to start with first row of the matrix received in this step, and we have to start examine how many zeros it has. Now the idea of the problem is each job has to be assigned to one person. So now we have to check that each row and column has 1 0. And so if we see in this row, there are 2 zeros. So let us not select any of the 0. Now here also in this row, again we have 2 zeros. So we shall move on to check the third row. So here also we have 2 zeros, and so we shall move on to the last row. So if we can see that in the last row, the only 0 available is this 0. So definitely we have to select this 0 for this row. So we shall select this 0. So once we are done with that, we have to strike out the corresponding zeros of that column. So after selecting this, we have to strike out this 0 and this 0. Now again we have to proceed with the same procedure. We have to check the first row, how many zeros it has now. Now this 0 has been striken off, so it has only 1 0. So definitely that 0 has to be selected for this row. Now next we shall move on to the next row. Now again this row has this single 0. So this has to be selected. Now because we have selected this 0, we have to check out the corresponding column. Now when we check, there is a 0 over here. So we have to strike off this 0. And so the only left out 0 is this for the third row. And if we see, job has been assigned to all the persons. Person A has been assigned job 2, person B has been assigned job 3, C has been assigned job 4, and D has been assigned job 1. So we shall conclude the problem by calculating the total minimum cost. Okay, so now person A, B, C and D. Now A has been assigned 2, B is 3, C has been assigned 4 and D has been assigned 1. Now we have to see the cost value from the original given matrix. Now in this place, the original value given in the matrix, the cost of that element is 12. And over here we have 7. And then this, so 11. So here it is 12 and here it is 7 and then here it is 11 and the last one is 8, and so this is 8. So therefore, and so the total minimum cost, you have to add all this and you have to find. So when we add all this, we get rupees 38 as the total optimum cost. Hope you all have understood this problem. Thank you.